Good evening everyone. Today I want to explain you all how to convert a decimal number to a hexadecimal number, and let us also write a C++ program for the conversion. So let's start with it. First let me write the heading. So the heading of today's class would be conversion of a decimal number to a hexadecimal number. So this is the topic of today's class. So let me comment this. So this is how we comment in C++. So before I start explaining the C++ program, first let me explain you how do we convert a decimal number to a hexadecimal number. Suppose, let us consider an example. Say we have a decimal number 679. So decimal numbers do have a base 10. So starting from the digit 0 to 9, we can include any of the digits between 0 and 9. So this is our decimal number 679 and the base is 10. So how do we convert 679? First step is we have to take the base of hexadecimal number. So what is the base of hexadecimal number? It is 16. So now you have to divide 679 by 16. So 16, what are the factors? 16 fours are, let me check it out, 16 fours are, so 64. I will take 16 fours are 64. So what is the remainder we got? 3. So this is the remainder. Then we have 39. So divide it by 16. So what are the factors? 16 twos are 32, right? If I go for the next step, 16 threes are, it becomes 48. So we will take this one. So 16 twos are 32. So what will be the remainder? 7, isn't it? So 7 is the remainder. Now, so we have to repeat this step till the quotient. This is our quotient, this is the divisor, this is the dividend, and this is the remainder, right? So I will mention it here. This is the divisor, this will be your quotient, and this will be your remainder, and this will be your dividend. So till the quotient becomes 0, we have to repeat it. So next, 16 twos are, once again we will go for 16 twos are 32. So what is the remainder? 10. Right. So next, divide it by 16. So we are left over with a single digit 2. So when we divide it by 16, we don't have any factors. So 16 zeros are 0. So what will be the remainder? 2. So we have 2, 10, 7 as the remainders. Okay. So now the quotient is 0. We have to stop this conversion. So we will take from bottom to up. We will go in this direction. First, so from bottom to up, 2 is the remainder and then next is 10 and then 7. Okay, so now in hexadecimal, how many digits do we have? We do have 16. So what are those digits? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, 10 is considered to be A, 11 is considered to be B, 12 is considered as C, 13 is considered as D, 14 is considered as E, and 15 is considered as F. So 10, 11, 12, 13, 14, 15. So in hexadecimal, these are the digits from 0 to F, right? So what is our remainder? Least significant bit, 2 is the remainder. So 2 we will keep as it is, no changes, because it falls within the range 0 to 9. Okay. What about 10? How do we write 10 in hexadecimal? We have to use this capital A. Okay. And next remainder 7. So how do we write 7? 7 falls between 0 and 9. So no changes are supposed to be done. So 7 we will keep as it is. So finally we get the answer 2A7 is the hexadecimal equivalent of the given decimal number 679. Right? Hope you all understood the conversion process here. The given decimal number is 679 base 10, and after conversion we get 2A7 of base 16. So this is the conversion process. So now we shall see how to write a program, write a C++ program for this conversion process. So now before writing a C++ program, you can include the heading in the comment section. So C++ program to convert a decimal number to a hexadecimal number. Alright, so close the comment section. So now the first step, as you all are aware of it, we have to include the necessary header files. So hashtag include. So the first and the foremost header file is iostream.h header file, because it supports to receive the input from the keyboard and as well as to write the output onto your console screen. So next we will see further. If we require any header files, we will try to include it. So next we will go for this using namespace standard. So these are the libraries. Now we will write a function for converting decimal to hexadecimal. Alright, so we will keep the name of the function as decimal to hex. So this is the name of the function. Okay, there is no space in between. This is the name of the function, decimal to hex. So in the argument list, we will receive a decimal variable, decimal parameter. So we will take the data type as int and let the variable name be decimal. Alright, so this is the function name and this is the parameter. We have a single parameter which we will receive it from the main function. So the next line we will open the curly braces, and finally we will return a hexadecimal equivalent, isn't it? So hexadecimal equivalent, as I have told you, it is in this form 2A7. As you can see, it's not convenient for us to use integer data type or a floating point data type. So better we will go for the data type string, because we have digits, alphabet in combination. So better we will go for the data type string. So now after input will be decimal input, but after conversion we get a hexadecimal. Hexadecimal is a string, so the return type we will mention it here as string. All right, so now we will start writing the logic. Okay, so first we will create an array of all the hexadecimal digits, right? So we will take the array of type character. So hexadecimal array we will take it. And what is the base of the hexadecimal? 16. So the array size will be 16, totally 16 digits. So we will initialize this array. So I hope everyone knows the syntax for initialization of character array. So open the curly brace, and each character will be kept within single quotes. All right, so the first character, as usual, it is 0, comma, next character is 1, then 2, then 3, then 4, then next line 5, 6, 7, 8, 9. So these are the digits. So after 9, how do we write 10 in hexadecimal? We will write it as capital A, then B for 11, C for 12, D for 13, E for 14, next line F for 15. So 0 to 15 we have 16 digits. So now we can close the curly brace and close the statement, initialization statement, with a semicolon. Then, so here is our array. So this is our input to the function decimal. So as I have explained to you, the decimal number has to be divided by 16 till you get the quotient 0. Alright, and we have to collect the remainders. So we will use a while loop, because we have repeated division till we get the quotient 0. We are using a while loop. Okay, so we will divide the decimal number by 16 and till we get the quotient 0. Once the quotient becomes 0, the loop should stop. So that we will keep this condition, decimal once greater than 0, the loops should stop. Okay, next line, open the curly brace. We will write the body for this loop. So our input is a decimal value. We will divide it. We will perform a modulus division by 16 so that we get a remainder, and we will store it in a local variable remainder. All right, so this is a statement. So once we get the remainder, we will concatenate with the next remainder. So we keep on getting the reminders in the repeated division, isn't it? So we will collect the reminders. How to collect the reminders? We will use the concatenation operator to collect the reminders, because reminders are the characters. So we will collect all the characters and form a string, which will be your hexadecimal result. So I will declare here a hexadecimal variable. which is a string, which is of string data type. I will take a hexadecimal variable and I will initialize it with a single space, which becomes convenient for concatenation of all the reminders. Okay, so next here, once I get the reminder, I am going to use this reminder to extract the respective character hexadecimal digit, to extract the respective hexadecimal digit from this array. So how to extract? We will use this array name hex, and in place of the index we will use this reminder, whatever the reminder we get. Okay, suppose say what is our first reminder. Once we divided 679 by 16, we got the remainder as 7. So 7. So hex of 7. What is hex of 7? Start from here. 0, 1, 2, 3, 4, 5, 6, 7. Hex of 7 is the same digit 7. So that will be your value. Okay. So now we will concatenate it. See here, this is a character array, hex is a character array. We are extracting the hexadecimal digit and concatenating with the string. Okay, what is the string? Hexadecimal. So, hexadecimal. So, 7. What is the first remainder we got? 7 is concatenated with the single space, right? So, and that will be assigned to the same variable, hexadecimal. Okay, so this is the step. And so, next step, we will check the quotient. We will collect the quotient. Quotient, how to collect? The decimal number. If we use the division operator by 16, we will get the quotient. Quotient, we will obviously store it in the same variable, decimal. Okay, so the loop should continue, isn't it? We will close this loop. Okay, quotient will be stored in the decimal. So after the first iteration, the condition is checked. If the quotient is greater than 0, the loop continues. If the quotient is 0, the loop will stop, isn't it? So now, what is the quotient we got? The first remainder was 7, but what was the first quotient? 42, right? 42 is not equal to 0, it is greater than 0. So the second iteration takes place. So second iteration, what is the value of decimal? 42 will be divided by 16. What remainder do we get? We get the remainder 10, right? So now find out the respective hexadecimal digit. Hex of 10. Where is hex of 10 in this array? Hex of 10 is here. Okay, that is alphabet A, character A. So we get the remainder, we get the hexadecimal equivalent as A. So previously what was the hexadecimal value? 7, right? 7 is concatenated with the next remainder. What is it? A. Okay, the first remainder will be your rightmost digit, and the upcoming reminders will be placed on towards the left. Got this? Hope everyone is understanding the logic here. Why we are using the concatenation here? Because we want to arrange the hexadecimal equivalent characters from bottom to up, in the sense left to right, bottom to up. So the bottommost remainder will be your LSB, the topmost remainder will be your MSB. So that's the reason we are using the concatenation. Okay, so now we got the remainder as A. So it is concatenated with the previous remainder 7. So now what is the hexadecimal value? A, 7. Alright, now what is the quotient? So what is the quotient when we divide 42 by 16? What is the quotient? We got 2. So now check the condition. 2, is it greater than 0? Yes, satisfied. So the third iteration takes place. So 2, when you modulus divide by 16, what do we get? You don't have any factors, isn't it? So the quotient will be 0 and the remainder will be 2. What is the remainder? 2. So hex of remainder, what do we get from this array? Hex of remainder 2. So we have the same digit 2. So now 2 is the remainder. It is concatenated with the previous reminders. So 2 becomes the LSB. It is concatenated towards the left of the previous reminders. So this will be 2A7 will be stored in this variable hexadecimal. So next, what was the quotient we got? What was the quotient? When we divide 2 by 16, the quotient was 0. So now the 0, check this condition, 0, is it greater than 0? The condition fails. So the loop stops. So how many iterations took place? 3 iterations took place. So what was the final hexadecimal result? It is 2A7. So now this result we have to return. This is a user defined function. We have to return this hexadecimal. It is a string 2A7. So these are the 3 characters which we extracted from this. So a group of characters will be a string. So we have declared the return type as a string. Okay. So now we are returning the string variable hexadecimal. Okay, now close the function. So this is the user defined function for converting decimal to hexadecimal. So next, how to write we have to call this function. So how do we call? We will define a main function. So without a main function there is no execution. So after defining the user defined function, you can define a main function. So we will take the data type, return type as int main. Okay, so open the curly brace. So we will declare a decimal, integer decimal, and we can initialize it here, or else if you wish to extract the input, decimal input from user, then you can do it, but I am initializing it here. So I will take the same decimal number which I took for the example, 679. So this is the decimal value. So now next I will print the hexadecimal equivalent. Hexadecimal equivalent is, so this is our user defined statement. You have to put it within the double quotation, and we are using the cout to print the statement on the console screen. So I want to print the value. So which was returned from this function. So which was returned from this function. What is the function name? I have to call this function decimal to hex. So the name of the function is decimal to hex. So this is the name of the function. And what was the parameter we were passing? We were passing the decimal number as a parameter. So this is our decimal number. So we have to just mention the name of the variable. No need to mention the data type in the call statement. That's it. Okay. So once this function is called and this parameter is passed to this function, the whole function gets executed, and the return value after execution of the whole function, a hexadecimal string will be returned to the main function and printed over the console screen. So this will be your final output statement. And finally, as I am using the integer return type, I will return int 0. So this is how you write a C++ program to convert a decimal to hexadecimal number. Thank you.